Let's begin. Today's November 10th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 12, 17, 19, and 20. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our first digit, the triangle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card B takes a look at our 3-digit solution, and the Turing machine will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card C takes a look at our first and last digits, the triangle and circle, and compares them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D again takes a look at our 3-digit solution, but this time it'll let us know how many of those digits are even. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again takes a look at our 3-digit solution, but it'll let us know a little bit about its structure. So the 3 scenarios include a 3-digit code that has no repetitions, as in the example 125. The Turing machine could also let us know that there's a pair or a double number in our solution, as in the example 112. Or it can inform us that there is a triple number, a 3-digit solution that has the same digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card A. Okay, so the Turing machine does not approve of my choice. Notice that I did pick an odd 3 in triangle, but since the Turing machine does not approve of that, it's letting me know that that digit is actually an even digit. So let's go ahead and type that up in our notes in section A. And we'll state that triangle is an even digit. And of course, since it is even, we can go ahead and cross out the 3 odds. So 1, 3, and 5. So let's see, what else? I always find it interesting when you have criteria card B, the number of evens, versus criteria card D, criteria card B, the number of 3s, versus criteria card D, the number of evens. I think it's safe to say you can't have 3 3s, because that would say you have 0 evens. And likewise, you can't have 3 evens, because that would mean you'd have 0 3s. So at least we can exclude that scenario from each of those. What else? Well, we do have an even. Let's test criteria card F. Okay, so the Turing machine does approve of my choice in proposal 314. Notice that all 3 digits are distinct in 314. And so, yeah, the criteria card F is letting us know that the solution should have no repetitions. So let's go ahead and type that up in section F. So we'll say that the solution, the solution has no repetitions. Let's see, did I spell that right? Repetitions. There we go. Okay, yeah, so we're looking for all three unique values. Well, so far we know that triangle is even. Anything's possible for square and circle. They both can be odd. We know they can't be both even, because then you would have a repetition. Or you could have two evens and an odd. So, let's see. Well, let's see. As we discussed, we know we can't have three evens, but and we do have a single even, so we know there can't be zero evens. So I think that this might be, well, let's see. It's always a toss-up between. Yeah, let's go ahead and test criteria card F. Oh, sorry, D, the number of evens. Okay, so it does not approve of my choice for a single even. Again, you can't have zero because you know triangle is already even. You can't have three for the previous reasons. And it doesn't like the fact that I have a single even. So in fact, we can safely, I think we can safely deduce that the solution should have two evens. So I'm going to say we're going to deduce the solution has two evens. Okay, unfortunately though, we can't cross out anything. So that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, the number of threes, which at this point we know there's only one odd and it's either a 3 or not. We also did not test criteria card C, comparing triangle and circle, and of course we didn't test criteria card E, the sum of the first 2 digits in comparison to the number 6. So of course a couple of possibilities are that the sum of the first 2 digits might be 6 if we do have 2 evens, but I don't see, well, it depends on what circle might be. If it is the odd, it might, criteria card C might inform us of which of the evens triangle should be. So if there is a 3 and triangle is smaller, well, we know it's a 2. So that could be the mechanism of how to, figure out what this solution is. What if the sum is not 6, and therefore triangle and circle would be comparing the evens? That might be it as well. So what would that look like? Because then that would mean that square is the odd. So if triangle is smaller than circle, it'd be 2, 4. But square, but square would, yeah, we do have square here that would help us. So it could be something like, if it is a 2, then the sum has to be less than 6, but it's between 1 and 3, which criteria card B would then inform us. Or it could be that 4 is greater than 2, and then the sum is going to be greater than 6, but it's between 3 and 5. So that could also be, and I guess in some sense that is a more interesting scenario. So the question is, what's it going to be in either case? So let's see, how would that work? How could we assure ourselves that? Well, I guess if the sum is not 6, then it would fall under that scenario. But the question is which one, and how do you sort of force the issue? Yeah, I guess the fact that it's not 6. Well, let's see. So if I set up a solution that is a sum of 6 and it fails, then I know it's one of those scenarios. And that would help us to at least figure out the evens among triangle and circle. Maybe I can still figure that out. Because if I choose, again, a sum that's less than, I don't know if it's equal or greater. I think I would rather eliminate the sum of 6 possibility. And would that be helpful? Yeah, let's go ahead and do that. I'm going to create a sum of 6 scenario. And I don't know if I'll be able to hedge my bets, but I'll try my best. So let's pick something like 2, 4, and 5, so that circle is greater than triangle. So let's go 2, 4, 5, and let's see how it plays out. All right, so just to double check, yeah, that first digit is even. We have 2 evens and no repetitions, yeah. Okay, well, again, the whole premise of it was that it was going to be a sum of 6. So let's go ahead and test criteria card E. Okay, so the sum is not equal to 6. So let's go ahead and type that up in section E. And what we'll say is that the sum of the first 2 digits, triangle plus square, is either less than or greater than. So less than or greater than 6. And again, so what that means is that square is not even. Again, we are dealing with distinct digits, and we have even, so we know there's a 2 and a 4. So that means that square is the odd, and that would mean that circle is the even. Okay, so even, odd, even. And let's now compare the first and last digits. So let's go ahead and test criteria card C. Okay, so that means that triangle must be 4 and circle must be 2. Okay, so far so good. So we've got our 2 evens, and let's see. Well, yeah, I don't know if there's any way around it, but let's go ahead and test criteria card B. Okay, so it approves of the absence of 3. So there are no 3s. Oops, did I forget? Yeah, I forgot to update my notes in C. So let me go ahead and do B first, though. We'll say that the solution has no 3-digit. Okay, so let's go ahead and cross out the 3. And we did establish that triangle should not be smaller than circle. We know they can't be equal at this point because of the no repetitions. So that means triangle should be greater than circle. We'll deduce that triangle is greater. And that is correct. Yeah, so we'll deduce that triangle should be greater than circle. But I do believe we're going to have to go to a third round. So let's just double check. Okay. So, yeah. So is it going to be a sum of less than 6 or greater than 6? So which odd should it be? And honestly, I really don't think there's a way to deduce that. Okay, well, we'll say 452. We'll test 452 in a quick third round, and we will test criteria card E again, the sum of the first 2 digits. Okay, so again, yeah, we're going to test E, and that is correct. So it is 452. It is supposed to be a sum that's greater. And so let's go update our notes here. And yeah, so it looks like the solution should be 452. And so let's just quickly review before we verify. And is that first digit even? It is. There should be no 3s. That's correct. The first should be greater than the last. They are. We do have 2 evens. The sum is greater. The first 2 is greater than 6. And yep, there are no repetitions. So that looks like the winner. I'm just concerned whether we beat the Turing Machine or not. Well, first let's verify. Yes. And how do we do versus the Turing Machine? Well, it is a 6 criteria card puzzle, but we did 7 tests. And let's see. So we did ADF in the first round, and we did the remaining 3 in the second round, and then did a quick third round test on E. So again, ADF. So A was incorrect, D was incorrect, F was correct, I believe B was correct, but C and E were both incorrect. And third round, we finally got E correct. And wow, okay, so we still beat it by 1. That is a bit surprising. I don't know why. I was anticipating the Turing Machine accomplishing the task in 6 tests. Again, I've been going back and forth between how to test criteria, or when to test criteria card F, the sum of the first 2. In past puzzles, that's always come back and hindered a win, because I would postpone until the second round. It did not affect it this time. I'm not sure if the hedging paid off from that perspective, but still got the win, so that's awesome. How about you? How did you solve it? What criteria cards did you choose, and in what order? And did you see anything interesting that you'd like to share? Add your thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, hit subscribe to be notified and not miss out on any future videos. Well, until next time, have a great one.